Hi, my name's Shao. I'm going to talk about SPatchGAN, a novel statistical feature-based discriminator for unsupervised image translation. This work's done at NetEase Games AI Lab in collaboration with my colleague Weidong Zhang. For unsupervised translation, some tasks can be solved by just changing the local texture, like the photo to Van Gogh case. Some tasks also require shape deformation. If we want to translate a selfie to an anime face, the shape of the eyes and the hairstyle has to be modified. We mainly focus on the shape deformation case because this is a more challenging problem, and in practice it's also more difficult to create paired supervision data for this case. A naive solution is using a generative adversarial network, but GANs are usually unstable and hard to train. A widely used technique is the SPatchGAN Discriminator. SPatchGAN has a grid of outputs rather than just a scalar. Each element corresponds to a patch. SPatchGAN forces the discriminator to pay attention to all the patches rather than a small discriminative subregion. The GANs can also be stabilized by constraining the generator. A popular method is cycle GAN, which requires that the generated image can be converted back to the original image. In practice, we often see defective patches with a SPatchGAN-based method. Why is that? SPatchGAN applies the same convolutional layers for all the patches. This is sufficient for the texture changing tasks, since the target texture is usually similar all over the image, but it's less visible for the shape deformation. And with the cycle constraints, some unwanted traces of the input image are often left on the generated image. Our motivation is to design a feature matching system which is more robust than the patch-wise distribution matching. We also want to relax the constraints on the generator. We design a multi-scale discriminator which relies on statistical features instead of individual patches. Let's focus on the first scale. After getting the feature maps of patches, we compute the key channel-wise statistics. Each element of the resulting statistical feature is calculated over many patches, so it's much more stable than the individual patch. It also has a global view of the entire feature map, which facilitates the shape deformation. We employ a multi-layer perceptron as a feature-level discriminator. Since the feature is robust and the MLP is dedicated, the output will be much more accurate than SPatchGAN. So basically, we build a practically achievable low-level feature matching system. We also reuse the feature maps and the model structure for the high-level scales to jointly stabilize the network. This is the typical output from our discriminator for the generated images. At the low-level scale, the outputs for the mean and standard deviation statistical features are very close to 0.5, which means that they are well matched between the generated and the real images, and the network is stabilized by avoiding the potential flaws that would break the distribution matching. Meanwhile, the high-level features are more discriminative. The generator is guided by these features for further improvement. After improving the discriminator, our network is stable enough so we can reduce the cycle constraints to a weak form. We only consider the one-way translation and reconstruct a low-resolution source image from the generated image. Let's see some applications. For Selfie-to-Anime, our method successfully generates anime-style eyes and bounds and a smaller face. In contrast, other methods often have incomplete shape deformation. Another common problem is the different color or size of the two eyes. Even if the individual patches are correct, the consistency is not guaranteed by SPatchGAN. Our method doesn't have this problem. Our method also facilitates the hairstyle change in the male to female task. Glasses removal is another interesting task which focuses on eyes. We can better reconstruct the eyes under the sunglasses with improved stability and avoid other redundant changes with a weak cycle. Our SPatchGAN also achieves the best FID and KIDs. If one of the statistical features is removed, the performance slightly deteriorates, but all the SPatchGAN cases are much better than SPatchGAN. Please check our paper for more details and analysis, and try it yourself with our open source code and pre-trained models. Thank you.